Hi, sir. So now I think that we can actually start up, and once the once this webinar goes on, then more people can keep joining us.
Okay, that's fine.
So yeah. So first of all, I would like to welcome everyone. I am Saurav Goel, currently pursuing my final year in BTech in Electronics and Communication Engineering from NIT Jalandhar, and I will be the moderator for today's session. So today we are having Mr. Vikram Virdi sir, who is there. The pass out of 2001 batch from our college, and we are really fortunate that he's there with us today for this talk. So let us have some brief glimpses of his journey. So actually he has started as an IC design engineer, where he joined SCL Mohali, and then he has worked in many tech giants like TI, Qualcomm, and Dubai Circuit Design, and ASEAN, and he has also worked in some of the IT companies like Capgemini Engineering as a director, and now currently he is working as a senior physical design manager at Intel Corporation. So we are really happy to have our such distinguished alumni with us today. So thank you so much, sir, for accepting our invi- invitation.
Sure, my pleasure.
Once again, we would like to welcome you for this talk. Over to you, sir. Thank you so much for.
Thank you, Saurav. Thank you for the introduction. And hello, friends. Hello, everyone on the call today. Saurav has been very patient and persistent to get me onto this call and talk to all of you. So finally, we are here. It only feels like yesterday that I was sitting in Saurav's seat and talking to the organizations and trying to allure them to come to the college and take the talent pool and interact with them. And I wish you all the best for the coming future. So let's get started. So we'll do this way. Probably I'll go through my quick introduction a little bit more in detail, how I have been in this domain and how I built the career in IC physical design, starting with my initial days. And towards the end, I can probably take up some questions accordingly for whatever's on your mind regarding silicon design as such. All right. Okay. So great. So let me get started. In 2000, so the whole history goes back in the year 2000 actually. So um, in the year 2000, the full semester, like you might always, you all might be having as well, a full semester was dedicated for industrial training. And even it goes prior to that. I mean, in fact, in year 1998, we were all going through a summer training in Bathinda, and in one of the um, conglomerate that was created, getting all the EC together in one particular location in one college. So PTU came up with the idea that all the domains should go into one engineering college. For example, electronics went to Bathinda, and computer science and mechanical probably came to REC Jalandhar. And as part of that program, we went to Bathinda, and there were some guest lectures, just like me talking to you guys. And that's when I was introduced to silicon design, when some gentlemen were talking about how the chips are manufactured in real world. And they were from Semiconductor Complex Limited, Mohali. And that was the time I got introduced in real sense on how things are actually working in the real world. And it gave me a spark, and I felt like going beyond what I had learned that day and see what are the possibilities of making a career in the domain. And to my liking, eventually I got lucky and was able to do in my internship training as well in design house in SCL Mohali, which later on, after passing out from the college, ended up into a job offer as well. So that's how the career initially started. Um, but it was not easy. In the year 2001, I almost had 3 job offers because of the tech boom. And to everybody's surprise, in the end, we had 0 jobs because everybody kind of backed out. And I kind of got lucky because SCL Mohali, being a government organization, they continued with their offer, and they continued to get us onboarded. And I chose to go there because that was my first choice, anyways. So that's where the career started, in silicon design, and I spent about 2 years there learning the basics of semiconductors and chip design. And we also still have it. I think now it has been part of ISRO, from I think year 2005 onwards. It was passed on to ISRO. Earlier, it was part of Department of Electronics. So in the year 2003, I chose to move out from SCL and came to Texas Instruments in Bangalore. And ever since, I have been in Bangalore after that. And I was there in Texas Instruments for about 2 years in the physical design domain. And it was catering to automotive industry, and the technology node was relatively not the latest, but much ahead of what we were doing in SCL. So after spending 2 years of career there, the opportunity came from Qualcomm, and I decided to move on because Qualcomm was doing latest technology nodes, working in the telecom domain, and that became a natural choice for me to move on. After Qualcomm, I moved out to a UAE-based startup, Dubai Circuit Design, and that was a very interesting experience where UAE government was trying to come up with the Silicon Design House in collaboration with Synopsys. I hope you guys know about this organization. Synopsys is a very well-known brand name, and it has been there for quite some time already in the industry, right? So spending some time there for 2.5 years, again, it was a realization that UAE is probably not probably connected with respect to silicon design industry. I chose to come back, and I started with a startup called SmartPlay. And ever since, the career has been going through very interesting curves, learning silicon design on the physical design aspect, and building a career in physical design further. I grew up to director, and now I decided to come back to Intel on a product side, and recently I've joined into Intel. Now, having told you all the story, what I'm trying to get you is it's the learning curve which you guys go through with your first job, with your second job possibly, or you may continue to be with the same organization as well. It's individual's choice and how you build that career forward. So let me just take a moment here and give you an introduction video of silicon manufacturing. I hope you guys have seen that already, but if you have not, just have a look how the manufacturing is generally done.
The world is producing data at an unprecedented rate, faster than our ability to analyze and understand it. To move, store, and compute all of this data requires incredible processing power. From the blazing speeds of our devices to blazing trails within AI, Intel builds chips that are at the heart of nearly everything. Within every Intel chip manufacturing facility across the globe, innovators are pushing the limits of science and literally rearranging atoms to create groundbreaking technology. This strong silicon foundation is what gives each Intel chip limitless potential. At the heart of all modern electronics, the transistor is a remarkable achievement that Intel has essentially doubled transistor density in every new generation of processors. The process begins when silicon-rich sand is melted and cooled, forming a solid, which is then sliced into wafers. Once inside an Intel fab, the raw wafers begin their long journey through an incredibly complex process. They're loaded into front-opening unified pods, or FOUPs, which travel hundreds of miles along Intel's automated superhighway, going from tool to tool, as processors are painstakingly built up on each wafer. The wafer first goes through a series of important steps, such as photolithography, ion implantation, and etching, that prepare it for the critical transistor formation process. Intel was the first to manufacture three-dimensional transistors called FinFETs. FinFET construction requires first building a channel in the form of a fin. Intel has devised several innovations to overcome fundamental barriers to continued transistor scaling. One such innovation is a breakthrough fabrication method called gate last. It involves building, then removing a temporary gate in order to precisely place the dielectric material and metal gate. This allows for the gate to wrap around the fin and control the flow of electrons through the channel. Another invention moves the transistor contact directly over the active gate. To accomplish this, the gate material is recessed and then filled with insulating dielectric material to prevent the creation of a short circuit. Next, the dielectric near the gate is etched, filled with metal, recessed, and capped to allow a novel self-aligning process that enables the high-density contact geometries. Now, the dielectrics are etched selectively to expose only the desired part to connect to the first metal lines. This is done through an innovative via etch and deposition scheme, allowing contact over active gate to happen. Finally, dozens of layers of metal interconnect lines are added to complete the circuit. After more than 1,000 of these complex steps, the wafers are finally prepared for singulation and packaging. Innovative processor packaging has become a critical feature of advanced computing architecture. 2D and 3D packaging technologies are enabling new device form factors and additional boosts in performance and energy efficiency. Testing of the final product ensures that every chip exceeds our performance and quality standards. In addition to adding more performance and features with each new processor generation, Intel's integrated design and manufacturing capabilities have enabled humanity to innovate game-changing technologies that impact nearly every facet of modern life. Intel keeps powering the world. At the same time, we're powered by you, the makers, the dreamers, the doers, the people who share in our history of making the world smarter, faster, and more connected.
All right. So, any takeaways from this video? Or any questions as such? You guys can type, or I'm open. Let's make it more interactive. If you would like to ask any question beyond this, you can type here, or we can take it later.
Sir, I have one question.
Sure, Gaurav, go ahead, please.
Sir, my question was like in the video, it was discussed about the FinFET process.
Yeah,
So, the FinFET process, like it stacks on 3D transistors.
right.
So, how it is like more compact than 2D? Because in 2D we are only using we are using two dimensions, and in this we have to deposit a lot of material. So, how it is like more compact?
So when you say compact, right, what does it mean precisely? It's like the number of gates per given unit area, you are increasing that. So as we are developing newer technologies, we are shrinking the size of the gates as we go forward. So as we are going in terms of shrinkage in technology, you are able to add more and more gates per unit area, and that's leading to higher density. And that's why you can see the system. The earlier the old age ASICs used to have probably in thousands or probably in couple of hundreds of thousands of gates, right? Now we have reached to a stage where we can have hundreds of millions of gates, even touching a billion on the silicon, and it is no longer being called as ASIC. It's called as system on chip. So you are able to have multiple units, or processing units on the single die itself, and that's the evolution of design what you're seeing. If you remember, if you just take an example of your mobile handset, the initial handset what you might have used or you have seen your parents using or your elders using, there was just a monochrome design and with a very tiny screen, right, where you used to just SMS. I don't know if you guys have used any of those. It used to be 20 years ago. Now today you can just use a handheld device which is having almost, as much computing power as a primary laptop may have. You can do as much in the phone as you would love, as you would want to do in a laptop. So as we are going forward in terms of technology improvement, there are dedicated teams in each organization which are actually developing and evaluating newer test vehicles to ensure that how much more we can push our technology further. And it is actually reaching to a stage where we are we are kind of limited by the atomic gap, and they are trying to find the new ways of taking it forward. And that's most of the organization who are able to crack it, they are keeping it very proprietary and internal. What you have seen as a FinFET is again kind of becoming old, and people are moving to triple FinFET, and things are evolving beyond that as well. So what I have just shown you is just an idea on how the manufacturing is generally done. And some of you might have seen it because during our days, we used to get this information and visualize it out of a book. But thanks to the technology and YouTube, everything is available to you guys. And so much information is available as open source. If you would like to learn and understand, there is no limit to it. I think you probably just need some direction there, and rest you can build a history on that. The idea is to just dream big and keep looking for your answers. Now, if we can just step back a little, I would like to answer a couple of more doubts, which I think Saurav had shared with me earlier. How one person can build a career from scratch up in silicon design. That's the primary ask, I would think. I mean, that's there as part of our um, the subject line as well, demystifying the silicon design career, right? So, how many of you are well aware of silicon design jobs? What kind of jobs exist in semiconductor industry in the design? Can some of you just type here what kind of jobs you have heard that exist in silicon design industry or VLSI? Feel free to type. That's fine. Just type what you know. If you don't know, that's also fine. I am anyways going to answer that. Verification engineer, yes. Design engineer, validation,
Digital design, analog design,
digital design, analog design, yes. What else?
SOC
The
designer.
physical design.
Physical design, yes, Meda, right. Now, each of these names or designations or skill sets you are referring to, it's just one big umbrella. There are further specialization in each one of them. So when you go and take up a domain, you get more and more expert in it, and then some of you can choose to become, say, physical design engineer. But in physical design as well, somebody would become an expert on sign off, which would be more to do with timing and ensuring that the mask which you are going to release to manufacturing process that has gone through all the electrical checks, and you become the sign off authority in that electrical check, which is of course done through a lot of EDA tool support, not manually now, because the complexity of design is so huge that you cannot do it manually. You need to have the EDA potential on that, EDA computing power on that. All right. So how the career generally starts is there are we used to follow at our time was probably if you get lucky, you get picked up by a brand name or a larger organization. You go through the examination process or screening process. Um, Generally, it is internship, then eventually getting translated into a full-time job. So when you have good window approaching your internship, you start knocking the doors of all the larger organizations, and then try to get yourself in as an intern. And through your internship performance and the right requirements, you get a job offer and it gets converted into a permanent offer from internship. The second approach is that you take up higher studies in this domain. Generally, the larger organization prefer master students because of the sheer complexity of the design and the complexity of the technology. And a lot more subjects are taught probably in the masters, which we probably are barely touching the surface of it in our undergrad programs. And through masters, they probably can come to the campus and take or host an open test or screening process for that. The third approach is you come out of the engineering college, you choose a very strong VLSI design school for a small diploma or a short duration program. But while selecting such a school or diploma program, you have to make sure that you must get exposure of good EDA tools. If there is no EDA tool exposure, all you are taught as theory is easily available and open source. And I don't see a need for you to spend your hard-earned money of parents to, for such an institution. You have to clarify with them first that what kind of tools you are using, what kind of exposure on the practicals you would be providing, which are more relevant for your job screening towards the end, which kind of gives you an early experience or a pseudo experience that you have used some of these tools and you are well versed with them. The major gap, which I generally see when we hire youngsters for almost 6 months, somebody with the background of Unix or Linux can be reduced to almost 3 months or 2 months because the person is already well versed with it. I have kind of built a charter of things in kind of a README note. It's more of an interactive session which I wanted, so I have not built any formal slides, but I will share that through Saurav or I will paste here in the chat window. You go through it bullet by bullet, and that will give you some direction and preparation. And the most important key here is the communication skills, but that's kind of generic statement. It's not relevant to only one particular domain as such, but no matter you're in hardware or software, but if your communication skills are sharp, you stand a better chance in getting through a job offer to get a better career ahead as well. So I would say that work on your communication skills as well. You should be very clear on what you're trying to convey. And I see that that's actually pretty good these days in comparison to how we used to have challenges in communication in our time. Now things are much better because of all the exposure students have. Yeah, I kind of make a rest here and take a couple of more questions. Any other question? Saurav, you have any other questions which you had probably taken from the students earlier? We can answer now.
So, like one question which I was getting was that, for like you have mentioned that for MTech, it is preferable for the silicon giants to hire. But like for BTech, what are the roles which are preferable? Like if we can presume that, or like we can get a rough idea of that.
So BTechs, see, you guys are lucky that you are part of NIT, and I'm pretty sure there can be a good potential for the brand name of National Institute of Technology for undergrad students also to crack one. But mostly what happens is the service organizations like the Wipros and TCS and Capgeminis of the world, they would hire a bulk pool and then eventually it gets segregated based on the performance in the screening test. And then they get designated into software or hardware or probably based on the choice they would have given. So you get some experience on that for a couple of years. And if you like that journey in services organization, for the variety of work you may be able to do, because it will be always project based and you may work with multiple clients, you can continue to be in the service organization. But after having about 3 years of experience, it becomes very easy to jump to any product base. Yeah, and it's not limited to hardware as well. Some of you probably are thinking that, oh, what if I'm getting a software engineer? job now? Shall I take it, or should I just focus on my hardware related or silicon design related job and try to crack that and put all my focus there? It's something debatable, but I would say you guys can go ahead and take the first job, what you get in hand, and continue with it. And in parallel, try to train yourself with your spare time. And if need be, you can take up a training school as well, and then eventually try to jump into a services domain or direct product company, which has silicon design related skill set requirement. All right. So, any other questions? I think you may have more questions, but I would like to know a couple of more things around what's the preparation you guys think are you doing, or you have any background what things are required as a skill set beyond Unix?
Sir, maybe some tools like Xilinx.
Okay. Xilinx is more on the FPGA, and that's only one small aspect of how the the circuits are designed, and it's more FPGA based. It probably has very less overlap with respect to SoC. Only from the design point of view, maybe RTL design would still have a common overlap, but there will be slight difference in terms of how we design things. Um, for SoC, it's more of a bottom-up approach, and for Xilinx and FPGA-based design, you have pre-constructed structured arrays, and then you have to do programming accordingly. Um, Now, the basic ingredients what you can prepare to apply for a job is, of course, you have to highlight that you are Unix, you have Unix background or Unix environment exposure. You have to highlight that if you have studied the relevant subjects regarding the VLSI. I can share some of the books as well as part of the reference. One very good book is CMOS Principles by Neil West and Ishragin. The first four chapters are kind of the Bible of starting into VLSI, and they're very, very basic. That's something I recommend all my engineers also who come in young, and you kind of get a refresher on that of every 2-3 months to be on top of that. Of course, the technology has evolved from that basic gate structure, but the fundamentals are still the same. So it is very good to just stay in touch with that. Other than that, you beyond this, there is a physical design domain, as I mentioned, and that particular domain has timing sign-off as a very key skill set. And there's a very good book on that by Jay Bhaskar. I can share that as well with you guys. Probably you give it a look, and it will give you an idea of how the EDA tools are connected with respect to designing and how the models are getting translated into silicon. So all what we are designing on computer aided design through computer aided design is based on the models which we have. Might it be your SPICE model or a .lib model or a Liberty model? These are all mathematical models which are reflection of how the silicon would come out in the end. And taking the use of that, we go through the EDA design process. Um, any other question from anyone else? Please go ahead. Hi, Satvik. See, I would look at it in a different way. It is more of what you like to do and what you are preparing to do in the long run, or what you have trained yourself to do. If somebody is really good with software, he loves to do coding, he definitely has a better job in software or IT side. But there is unlimited opportunity in hardware as well, because as I said, all the designing is happening through computer aid, and that is again through a lot of programming. And these tools can work to the maximum efficiency which you when you have a very good strong background in coding as well. There are basic tool command languages which you will have to use, or basic Perl scripting which you may have to use to create a wrapper around different command lines to stitch the flow or create that automation. So it is again a relative choice what an individual would make. Regarding salaries in the long run, I would say it is kind of apples to apples, or sometimes we are better than software. I would say not sometimes, mostly we are better than software after 5 to 6 years of career. If you have gone beyond 3 or 4 years of career, you can look for a salary of higher of 4 to 5x of your experience, and it can be sometimes 6 or 7x depending on your niche skill set. So, for example, if I'm saying a person having 5 years experience can easily look for 5x or 6x kind of a salary, so 25 to 30 lakhs. The starting may be small, which is similar for software as well. I hope I answered your question.
Sir,
Yeah, it's yeah. Gordon, go ahead.
sir, I have one more question. As you said that Xilinx is more of a FPGA type software. So, like, there are some for ASIC design or SoC design. So can you tell more about that?
Sure. So from ASIC design, what industry generally uses are two main vendors. What we are engaged with are Cadence and Synopsys, and they have their own set of flows which are in parallel in terms of production and financial or economic dynamics, because these tools are very expensive. So if a larger organization is getting a good deal from Synopsys, probably they would go with Synopsys. And if a smaller organization gets an exclusive deal with Cadence, they may want to go with Cadence. So it's a relative call they make based on the, the economic and the best business standpoint call they take. Now, particular tools which I can name here are the which are the latest in the market. Our Fusion compiler, for example, is a primary tool which is being used right now from backend perspective. And Innovus is another tool which is being used by Cadence. A Fusion compiler, by the way, is from Synopsys, and Innovus is from Cadence. And There are tools beyond this like Primetime or Genus, which are again from Synopsys and Cadence. And if you don't get access to these directly, there are some tools which are available as open source as well. You may have to search it out. It's been a long time that I have not been exposed to the open source market. I think then when we used to be student, we used to find some academic versions of these equivalent tools which we would want to download and set it up as a lab and then try to explore that. I remember Tanner used to be the one during our days, but I think later on it got sold to a larger organization and was not open source anymore. Yep. So I think I can share that as well. And beyond this as well, I will share my LinkedIn portfolio as well, from a LinkedIn profile link for you guys. You can reach out and drop a note to me. I'll try to give you the answer. It may be little delayed, but I'll try to give you something as soon as possible, if because of the actual engagement we are involved in, it gets really difficult to get a time out sometimes.
Sir, one more question was coming that like we've seen TI and Nvidia hiring BTech people, but like Intel, kind of goes back and is not showing that kind of
I think
interest in.
that's a good question though, but I would want you to take it up with your placement cell.
Yes.
And as I said, it is organization to organization decision what they take on. It's a good thing that Texas Instruments has taken and NVIDIA has taken, which gives a strong testimony for people coming from Intel for hiring.
Yes.
Have to take it up with the placement cell, trying to convince Intel for the same. One major reason could be that Intel has a very strong internship program, and a lot of engineers get consumed through internship. And what remains as a college hire is relatively a lesser number. So the number of hires required generally are relatively small in the fresh batch. But I know that it's a concern, and I have spoken to uh, Mamta ma'am as well. And I think we'll work something out. I'll talk to the relevant department and try to find an answer for this. What is the main reason why they can't go ahead with the undergrads? Ideally, there should not be major reason for this.
Yes, sir.
So for all the students who are really keen to build a career in silicon design, this is kind of one of the best times in looking at the history, because you can see the government of India has also put in a lot of focus on that. There is a 10 billion policy charter which our current government has released. So we are just hoping that this will actually boost our economy in terms of silicon design, and the relevant jobs that it would create. You might have heard the news about Tata's coming into this as well. So there's a lot of excitement in the industry for same, but it will reflect probably 2 to 3 years down the line. Um, so right now it would be a good time to probably prep yourself into this, and then eventually land up with a better job in the long run. But it's not something which should look at only from a job perspective, but look at from the technology contribution perspective. Because if you take anything which is electronics today, or if you take anything which is technology related, semiconductors and silicon design is in the heart of it. You pick anything and everything which has technology, it has semiconductor in the heart of it. And being a silicon design engineer, you can imagine what kind of horizon you would be building around yourself. You would have unlimited number of opportunities in the long run. And I can say that I am kind of living in the future, because when we started, I wouldn't have imagined this kind of technology happening in our age or our lifetime, which we are able to use. Um, look at about this, just a mobile phone, right? I mean, you have so much of data available on your hand right now. Who knows, tomorrow something gets evolved from this, and one of you would be participating in that technology. So it's a good time to probably build that direction and work towards it. Any more questions regarding a career or job in silicon design, about anything else you have in mind? I think I've covered a major aspect about the salary. So you guys got a pretty good idea. I mean, the salaries are not less for sure.
So one more question was coming, like how much coding experience, or like people in software do competitive programming, right? So is it going to help them out in VLSI sector as well?
If somebody is doing competitive programming, that person is much more or better suited for an EDA company. And all these organizations like Synopsys and Cadence have a very strong R&D teams as well. So they need a good mix of a person who has a strong hardware background and a very good coding experience as well. So that's where you can go in and solve complex design problems, which they are not able to solve because of design challenges or because of uniqueness of the design. If you're going into competitive programming, of course, you can go and help them out. For example, a lot of these tools are being pushed into artificial intelligence, where they can do a basic structure designing on its own with very less commands. And it's self-learning. In the long run, they should be able to do much more on their own. That's the kind of direction it's trying to take. But nonetheless, it is not going to reduce the jobs, to my understanding, because it is only going to speed up the process of getting silicon in your hand.
And one question was coming from the first year guy. He has actually asked, like, what do you think that up to what up to what extent has the industry been automated till now? Means, is it completely automated, or like it needs kind of.
See, when I say the word automation, it's a generic term. It doesn't mean that you're sitting on a laptop and you push a button and everything is done. So there is a lot more to that. There is lot more to that. As a design engineer, you have to set things right. And there are you guys would have heard about system design as part of your curriculum. A first year guy may not, but final year guys would have definitely. A system has boundary conditions, right? So all these boundary conditions you are defining through this computer aided designing, and those boundary condition definition itself can be a strenuous process, which has to be done, which has done, which you have to do through a manual intervention, and constraints creation or boundary, boundary conditions creation is not something which we can automate unless you are doing some legacy work, which has already happened and you're doing some fine minor tweaks. Probably that's what you can tend to automate and then push it through the flow. But in general, for every step of the way, all these tools, all these scripts or flows what we have, they have its own challenges and bugs. So with every step you have to go through the log files, you have to ensure the errors are not there, or if there are errors you have to clean it up. And there is definitely a lot of manual intervention as of today, and I'm not seeing that going away anywhere in near future. It's just that efficiency of these tools are going to increase, but the manual intervention would definitely be needed.
Excuse me, sir.
Yeah, go ahead, Gaurav.
Sir, as we have seen that in silicon design, there are different design like FinFET and triple FinFET, as you told. So how these designs are like formulated, or how they come up with the design like, yeah, this will be more efficient than the than which we are using today, or this will
For
be.
example, if you create a structure, right? How do I explain this? Like I said in early discussion, right? These are done through test vehicles or test structures. So the dedicated team who is working only on the process node or the technology node, they are having their 24/7 job. And some of them are experts in engineering, some of them are experts in physics, some of them are experts in chemical engineering. Because in the end of the day, it's not only designing that's important; it's manufacturing that, and that delivers you the silicon, right? So they have to optimize at every aspect of it. So they keep developing these test structures which go through the whole process, and then they are evaluated for their performance. When I say performance, in terms of if they are shrinking it, is it able to carry enough current through it, or it is just going to fuse? What is the voltage it is going to handle? How much voltage it can handle? How much current it can handle? So all these electrical features we push through in or pump through in and take a log of it, and then eventually it's a cyclic process, a iterative process. And then when a structure is created, it may actually be alive for some time, and it may die down with some stress of the electric field, and all those things have to be evaluated. And over a period of time, the structures have to be robust as well, so that once you take it into production, the chip should not fry on the first or second cycle itself, right? It should be functional for at least a couple of years. And similar challenges are there. I mean, just to add beyond this, for the structures which you might be using in or chips which you see we might be using in space, or for automotive, there is a lot of redundancy that is built into it. For example, there is a standby structure in it. If one structure fails for whatever reason, there is a standby structure that takes over. And it is not only in aviation that you have a standby engine. In circuit design also it is a concept, especially for the chips which are dedicated for your satellites, or for your you know maybe your space station, which is having so much of radiation exposure or cosmic exposure. Okay, I think it is too much of GAN and very serious talk what we have done. So let's talk something casual maybe. I would like to know what you guys would want to do with your careers. I mean, what are you interested in? What kind of job you're looking for? Are you guys looking for only good salary, good career path? Maybe some of you can talk. Let's make it a little more interactive. I think I've been talking mostly. What's the one thing you guys are looking from your job? The top priority. How about you,
The
Sai?
work culture.
Gaurang, yeah, go ahead. Work culture, right? Okay. What do you mean by work culture? What do you define as work culture?
so that having less tension about that, and we can go freely at 6. It should not
Correct.
be pressure on weekends to do the office work, and we can spend time with family, having gratuity, pension, like things which are important after
Okay.
retirement.
Okay, Abhinav, I hear you loud and clear. Um, Interesting thought, but I can tell you one thing. This is something which you will learn when you join. It's a very good point you have raised, and the the hazard of our jobs is become in multinationals is that some of us don't know how to manage it. But as you grow a career in the domain, you will know how to manage it. Don't go by what you see on TV or what you see in the soap operas or OTT programs. You will know how to manage it. And there is no boss who would sit and bring a gun on your head and say you have to do this on the weekend. If they need a requirement, those are probably very short duration requirements, which are generally towards a project end, because a lot of things tend to pile up towards the end, and you have to make sure you deliver a good quality product as part of a team, right? And if you have a sense of responsibility and belonging and the interest of ensuring that what task you have taken, that it should go with high quality, it will not look like a burden but rather an interest. But yeah, having said that, if you're looking for 9 to 6 job with gratuity, pension, everything, you're better suited for something more formal format, which you know what I mean, probably a government job or something. But in multinational, no matter what you do, and there are expectations from you, and you have to deliver beyond the call of duty sometimes. And I think that is becoming part of every job now. It is not limited to MNC. What if you become a cop or go to defense services? You will have a 24/7 job, right? You won't even have a weekend. You won't even have a holiday. What if you go into media services? You will be most busy during holiday season. So it's a perspective you guys have to build. It is not just something which should crack you down upfront thinking, oh, this is high pressure oriented. Will I be able to take pressure? Yes, definitely you'll be able to take the pressure. If you have gone through proper training, if you have shown proper interest, if you have built your basics and fundamentals right. I mean, even if today it's not too late, if you can start building now, you still have time. You can do that. We all know engineering 4 years. You all would have had fun, right? But the real work starts after the 4 years. I hope I answered you, Abhinav.
Yes, sir.
I'm sorry if I did not give you appropriate to your liking, but that's the reality.
No, sir. So from the starting of my 4 years, I was seeking for a government job only.
Okay. All the best to you.
Sir, what were your special things which you actually which you would like to share, with us, with your college days, which you enjoyed, or kind of learned a lot through those, some just quick glimpses of those days.
Yes, one thing I can I can tell you is like I was in fourth year and I was not having any job at hand at the time. I had 3 offers and all got rejected, and I was sitting. But you know how this time is. You would want to do something good with your life. You want to make something which has a major impact. You want to belong somewhere. So I was looking for something which I started looking at the latest technologies which are actually happening in the market. During our time, optical fiber was coming up, and a lot of research was happening on optical fiber. And I found this really nice course in Singapore, and I thought I should apply. And I did not have a computer, and I was sitting in Khosla sir's office, I remember, and I started applying using his computer. He was sitting next to me, and I started typing my email. And I still remember he shouting at me this after seeing that email, because it was no less than sorry for the word, but crap. Because the kind of language I would have used, it was very very basic, and it had no impact. And I have never forgotten the day, because that gave me an awakening, a sense of awakening that how important it is when you make a first impact or first email or first interaction with somebody through email, because somebody is not seeing you, right? I mean, wherever it's going, the person is not seeing you at all. So you have to make the best impression. So how would you do that? So we worked it out together. Of course, he typed everything for me, but I can't forget that those were really good days. And there are many, many other occasions and events which we did. I think I cannot mention all of it here because of lack of time, but yeah, those were great days. I think we have about 64 people in this call, including myself. Is there anybody from faculty here today?
Actually, Mamta ma'am was going to join, but as she's
Okay,
traveling, so
no problem.
she's getting some network issues.
No problem.
Yeah.
Okay, how about the remaining 60 students? Anybody has any question regarding myself, job, salary? Because that's a big question, Margaret, how much money I will make.
Excuse me, sir.
Go ahead.
Sir, how you see that in semiconductors the research is going? Because as in the video, like we are trying, we have reached the atomic ranges. Like from that point, we can't shrink the transistor. So like we are looking for new materials or like some new techniques.
Yeah, I'm sorry, but I don't think I rightly said. There is a lot of research going on lithography in terms of what kind of um, what kind of rays which we can use for photolithography. Of course, what kind of photoresist we can use, or what kind of new materials we can use as a base material beyond silicon. So definitely that's an ongoing process, and I think it's never ending, and it will continue forever, um, unless we come to a point where there is altogether a new washover and we have a completely new technology which is beyond silicon or the current way of doing things.
So I think one very important question which was coming was that what do you think is the major difference in the analog and digital design roles?
Sure,
What are the major differences?
sure. That's a very good question because, um, to my understanding, if I say on a larger view of things, everything is analog. Everything is analog. What we call as digital is a subset of analog where you are sampling the analog signal and converting into digital. And in your SoC design, everywhere, wherever there is a digital aspect, there is a precursor to it, which is analog. So there would not be any SoC which will not have any analog aspect or any analog circuit in it. So there will be an ADC definitely or DAC associated as part of the circuit. Now, major difference in the two is in analog design, you would be working at the transistor level. You would be working at the silicon level where you would be tweaking the features of a transistor. Now, if you see a transistor, it acts as a switch, right? And its current carrying capability can be varied based on the change in the length and width of the transistor. So you play around with the length and width of the transistor or different architectures of how you are connecting those circuits. But when you are playing at the digital side, you already have pre-constructed structures which are gates or digital gates. So all your designing is limited by using those gates. You have those basic gates, as you know, right? Your NAND, NOR, inverter, or a D flip-flop or any such variables. Eventually, that's what you would be using and taking your design forward. So there's a lot of difference in terms of analog and digital design. Analog is lesser scale, but on more intensity on electrical designing, I would say. And digital is much larger scale because number of cells would be much higher, and it is more automated. And most of the designing is happening through your VHDL or Verilog coding. I hope I was able to give a brief idea on the two.
Yes, sir. Yeah.
Sure. Before we go into more questions, I just want to paste a couple of charter points here. This is a food for thought for you guys later. Spend some time on this. I hope it's coming correctly. No, I think it's limited by number of words I can type here.
So
So
you
what
can also
I can do
share it
one
to
thing,
me.
Saurabh, I will send
Yeah.
this to you on email. You can pass
Yeah.
it on to the engineers.
Sure, sir. We'll do that. Sir, if you would like to, share some coding experiences with us in your BTech.
No, I am very bad in coding. That's why I'm in silicon design.
Okay.
Otherwise, I might have taken a software job, but I am very bad in coding. So
But
coding is not a
yeah.
criteria. It's not the basic criteria, I would say. All you need is basic functional knowledge. You don't have to go creating complex programs using data structures or arrays and all that. You just need basic programming. Like if there is a file of 1,000 lines, or which is not easy to edit manually, you should know how to do a change in that which reflects based on a pattern match. Or maybe write a simple code in a tool where you want to pick certain pattern and change it to a different pattern, or pick certain cell and replace with another cell, or change a gate into a different cell, or change a net for connectivity from A to B or B to C or whatever. So as you get more exposure, you will know that it's not very complex programming that is what is required of. So I personally am very bad in programming. So that's an example for you. You don't have to be an expert in programming, but you should know basic scripting knowledge. That's all what you need. By scripting, I would say for each loop is probably is lifesaver every time. Even if you know basic for each loop, you're fine. But yeah, that's not enough to get through screening. So like this, so on the similar note, I had built a charter that what kind of books, what kind of languages or scripting language would come in handy. Maybe it's good idea to just share my screen for a minute.
Yes, sir.
Let me know if you can see what I have written here. Can you see this?
So have you shared the screen?
Yeah.
Is it visible to others? I cannot see it.
On my side, now visible.
Now it is visible, sir. Now it is visible.
Okay. So the one you see on the top is the link to my LinkedIn profile. You can just connect through that and reach out for me for any queries or any further direction for career. These are a couple of YouTube videos which I found might be relevant to the topic which we are discussing today. You can go through it one by one at your leisure. Then coming back to the key skills which are most important, which will prepare you for a screening test. The first and foremost is definitely communication skills. Having business communication or behavioral skills is very crucial to first impression and making sure you get through the screening. So it would be a great idea if you guys go through GDs or some kind of debates internally within your groups, or make a group and go through that and try to host it as formal as possible. The second one is again Unix environment, which is again I've mentioned clearly. It is user level basics. You don't have to go into deep diving on how Unix programming works. That's not what we are expecting. A very basic shell scripting. This is mainly required for automation when, for example, some procedure or task is finished. Based on shell scripting, you can stitch it and make it automated. For example, step one completes and generates some output. You should be able to figure that if that output's created and kick off a step two of that. And similarly, step three and so on and so forth. And if your number of steps are, for example, 5, after fifth step, it should generate some kind of report. That's very basic scripting. I think that's what is required of. Now, GVim or Vim, anybody has used here? or VI editor?
It's used in Linux, just had a kind of experience once, not remembering much of.
Yeah, so why I have mentioned this is against Notepad or any of the basic um, texting tools or text writing tools. These have lot more macros built into it, where you can easily do a lot of um, text processing. For example, if you have 1,000 line code, you want to find a pattern and replace it with something else, you can easily do that. If there is a complex process you are doing for text editing, which is 5 or 6 steps or more, or maybe hundreds of steps you have done, you can record it and play it again and again as per your choice of numbers. You can cyclically run it. So these are the best features about GVim, Vim, or VI. They're slightly different from each other. GVim is graphics oriented; it has a GUI. Vim has relatively lesser features, and of course, VI and Vim are kind of at par. Then there is Perl and Python. So this is again at scripting level. If you get an opportunity to do Perl and Python learning, that would really be a boost. Preferably Python. Perl is kind of getting old, but yeah, if you know Perl, and that's also fine. Tool command language, of course, this is the very basic tickle scripting which we need or use as part of any basis of the tool programming or tool usage. Like I mentioned, some of the tools earlier, like Fusion Compiler or Innovus, together and do some processing around it. Verilog and VSDL, I think you guys are covering as part of your UG program as well, right? But
Yes, sir.
give it more stress to write some complex structures, take it beyond adders and subtractors, try to write some complex design and see how it evolves. Digital electronics is a wide subject, of course, but go through the basics of it. You should know at least to a stage where you should be easily able to design a very basic digital circuit of adder, subtractor, or counters. That's the basic ask generally we have in screening process. Now, books for referencing, I have mentioned here, as I mentioned, Dave Haskar is very good book, which gives the first-hand experience of technology and the electronic or computer models which we use for timing closure. It will give you a very good perspective of how EDA is connected with the manufacturing process. Then your principles of CMOS and VLSI design will give you very basics on transistor level. Go through it. First 4 chapters are really good. It will give you an eye opener. For analog design, people who are more interested in analog design, they can go through Design of Analog CMOS Integrated Circuits by Behzad Razavi. This is also a very good book. This will give you an idea on how an electronic circuit, analog circuit is designed using basic transistors and how they are tweaked. What are the different architectures which evolve into certain structures like op amps or your circuits relevant to analog design. And like this, some of you already have mentioned these job profiles. Digital design is one, analog design is one, RTL verification or general verification engineer. Design for test is also very not upcoming, but very uh, in demand field where you are responsible to ensure that how much testability is possible in a given digital structure or design what you have created. So, as a DFT engineer or design for test engineer, you have to ensure that you are increasing the testability to nearing 100% to ensure there is no fallout in the design in the real execution. Um, Having a higher number achieved through a DFT engineer is again an engineering problem to solve. It's not just a tool that runs and gives you a coverage. You have to go through a lot of design problem solving as part of DFT engineer. Physical design sits in the hub of it as the last step before the manufacturing process, because here is what we do the actual silicon designing or physical structures which are getting created and get translated into the mask, which further gets utilized to create the silicon or have that photolithography or etching process, all that happens through these masks. And of course, the silicon validation, where you have the silicon and then you do certain checks on that. So I would send this simple cutout from what I thought would be a directional knowledge for you guys. And based on this, if you go finding your answers, you will get direction. I mean, if you go searching on blogs for what a digital design engineer is, or what an analog engineer, design engineer would do, or what an RTL verification engineer do, you will get a lot of data in that. So it's very difficult to put everything in 1 hour, but try to go through it and see what is more likable for you guys, and then have a reference to it. I am from physical design background, as you might have seen as part of my introduction, and yeah, all of these are indispensable domains. Physical design more so, because we are the ones who handshake with the manufacturing side. So we are 15 minutes up. I hope I was able to communicate some quality information to you guys. Um, I hope you guys did not feel that you wasted 1 hour of your weekend. If you still feel more queries coming to you or any doubt coming to you later on, please reach out to me. I would be more than happy to help and give some direction within my capacity. Any last questions? Any more doubts or queries you have, you can ask.
Sir, how much testability we have achieved today in
Today,
design?
today we are going in the decimal place beyond 99, so it's relatively high. Earlier, people used to work with 90+%. Now, in real world scenario, it depends on the design as well, but some of the designs definitely reach beyond 99.
So, sir, means that testing side is more of an application specific, like in which application the chips are being used.
Yes, because the structures and designs will be different for each application, right? So you have to develop different strategies for testability.
Okay, sir.
So I think this was one of the most mesmerizing session for all of us, and we had really learned a lot and gained a lot of insights through it. But we hope that and we'll really keep connected with you, sir, and we really hope that you'll you'll just keep on sharing these insights with us regularly, and and we also hope that you will visit the college physically, and we'll have a meetup soon. And thank you so much, sir, for devoting your time. And we really look forward to you in the future as well. Thank you so much, sir.
Thank you everyone, and thanks Saurav. I would definitely would like to come and visit college. It's been more than, I think, 15 years I haven't been able to come. But in my next visit, I definitely would want to come and meet some of you in person. And I hope you guys um, have some direction now. My idea of having this discussion is at least some of you would come out motivated to take a job in VLSI design, and I hope I was able to achieve that. If with some of you, that's my goal achieved, then thanks.
We look forward for that, sir. Thank
Thank
you
you.
so much, sir.
Thank you, everyone. Have a good
Thank you,
weekend.
sir.
Bye.
Thank you, sir.
Thank you.